Okay, hello everyone. Now we are going to discuss about the performance on the Pelton wheel turbine. First, I am going to explain what are the parts of the main parts of the Pelton wheel turbine and what are the readings should be taken to calculate the unknowns. Those things I am going to discuss. Later, we are going to start the turbine and we will run it and note down the values also. After that one, I will explain the calculation part also. First, let us discuss know about the main parts of the Pelton turbine. In the Pelton turbine, the main part is the first one is the what we're going to call as the penstock. What here we can see this the long pipe. We're going to call this one is what penstock. After that one, we come to the turbine part. Here we can see that here the runner is there along with the bucket is also is there. So this one is the runner and the runner is connected to the shaft and where the shaft is further connected to the generator to produce the electricity, but here the shaft is connected to the brake drum to apply the load over the shaft at a different speed. And also to control the water, this is the mechanism here is there. This one we are going to call as the wheel and the spear mechanism. There is a conical shape rod is there. By moving this wheel we can control the water over the turbine. For different speeds we can control the flow of water through this mechanism. And in this experiment we are going to note down the turbine speed as well as the head on the turbine by using this one, and also we should calculate how much the flow rate is there using this, V-notch setup, and also what is the load is acting on the turbine can be noted down from this brake drum dynamometer. So this is the main part of the turbine and also the main readings to calculate the performance of the characteristics of the Pelton turbine. One is the speed over the turbine, head on the turbine, and also the flow over the V-notch and as well as what the load acting on the turbine. That is calculated from the brake drum dynamometer. Actually, the performance can be calculated by two ways. One is on constant head on the turbine. Constant head means we are going to maintain this head on the turbine is constant and we are going to vary the turbine speed. And another second method is the constant speed. In that one we are going to maintain the speed is the constant and head on the turbine is varied and the parameters is not known and the unknowns are going to calculated to calculate the performance of the turbine. Now we are going to start the turbine and the different readings will be I am going to show that one. Okay, the experiment on constant head on the turbine we are going to conduct right now. In that one, what the head on the turbine, this one is we have to maintain the constant, but the speed will be changes after applying the load. We are going to apply the load by incremental. First we are going to apply the load at 1 kg, later 2 kg and the readings will be noted down. At the same time the flow through the V-notch is going to be noted down. First initially we have to set this needle to that water level. Later once the water is coming, that time we have to change this needle and note down what is the scale and that reading we should be note on that one. Okay, now I am going to start the pump. Actually, before starting the pump, you have to do the priming. Priming means filling the water for the parts of the pump to remove the air gap. Once the priming is done, then we have to start the pump. Otherwise, pump wheel is not going to on. Once water is completely filled, close that valve. Now we are going to on the pump by pressing the green color button. Now the pump is on. You can see that one. The water is hitting the runner. At the same time, you can see the speed also, speed of the turbine. At the same time, you can see the head of the turbine. Now the load is we are not applied any load. There is a zero load. Now we are going to apply the load of 1 kg, but we are going to maintain the constant head on the turbine, but the speed is going to be reduces. Now we are going to apply the load on the turbine. Now we applied the load of 1 kg over the shaft. Now the reading is note down. This is the speed in RPM, revolution per minute. At the same time, we have to change the this V notch needle also. We have to take that needle and place to the surface of the water. Now this reading should be taken. Initially it is what in the here. Now it is raised to almost 70 mm. This is the head over the notch, small letter H, head over the notch. Likewise, for the different load we have to do the calculation, and different reading should be load down. In the same manner, we have to conduct the experiment for the constant speed. There we have to maintain the constant speed with the help of this mechanism, the spear mechanism. Now the next part is the calculation part. Okay, already we discussed how to conduct the Pelton wheel. Experimental part is forward. Now I am going to discuss the what calculation part I am going to discuss right now. Calculation part I am going to discuss the Pelton wheel. See, you can conduct the experiment by two methods. One is the constant speed and another one is the constant head. For the constant speed, the speed will be the same for all the different cases, 1, 2, 3, how many readings we taken, the speed will be constant. Head on the turbine, we are going to take in kg per centimeter square. Next, we're going to convert into meter just by multiplying by the constant 10, it will be converted to the meter. Head over the notch will be calculated using the V notch, how much of the head over the notch. Using this value, we can calculate the discharge. After that, one input power can be calculated by using this equation, rho q g h. H is the head over the turbine. We have to substitute the values, 100 by 1000, we get in the kilowatt. That value will be kept it here. And the spring balance is the what the load on the turbine can be taken in the that is the brake drum reading. F1 and F2 you have to taken. That should be in Newton. What is the value taken? That is in the kg. You have to multiply by the 9.81. That should be converted to the Newton. Then we have to take the difference. And speed, we know that one multiply by the speed. And R is the radius of the brake drum. That is the value that is given in the experiment itself. And we have to divide by 60 because the speed we taken in the revolution per minute. We have to divide it by 60 to convert into the second. And what the answer you get it, that is the output power. Next is efficiency is how, that is very simple. Output power divided by input power, you get the efficiency. This is the calculation method steps for the constant speed. Next, for the constant head is everything same, but we have to calculate the unit power, unit speed, unit discharge. That one we have to calculate, and specific speed of the turbine we have to calculate. The formulas are everything is the same thing, but only for what unit power, unit speed, specific speed, the formulas are here. That those things we have to substitute and we have to calculate the unknowns. And this is about the calculation part for the constant head. Thank you.